Hello friends, myself Praveen Gore, lecturer Science Department. So in previous lectures, I have covered few topics in mechanics. So in this lecture, I'll be starting with parallel forces. Then we'll see types of parallel forces, that is like parallel forces and unlike parallel forces. Then we'll see what is moment of a force. What is moment of a force? Then we'll see what is positive moment and negative moment. Then we will see conditions of equilibrium of coplanar parallel forces. So to begin with, we'll first go with parallel forces. So what are parallel forces? If two forces act along the parallel lines, then they are called parallel forces. If two forces act along the parallel lines, then they are called parallel forces. So say I have a body. One force F1 acts in this direction, F2 acts in this direction, F3 acts in this direction. So in this case, I can say the line of action of F1 is this, the line of action of F3 is this, and the line of action of F2 is this. So I can say the line of action of F1 and F3 are parallel to each other. The line of action of F1 and F3 are parallel to each other. Whereas the line of action of F1 and F2, they are not parallel, but they are perpendicular. Therefore, which are two parallel forces here? F1 and F3 here become parallel forces. F1 and F3 are parallel forces. F1 is acting here and F3 is acting here and F2 is here. So if I can say F1 and F3 are parallel forces. If another force is acting in this direction, then what is happening? F1 ka direction is this, the direction of force F4 is this. Therefore, F1 and F4 are also parallel. The directions are opposite, but they are parallel forces because their lines of action are parallel to each other. So these are parallel forces. Now we'll say what are like parallel forces. If two forces act in the same direction, then they are called like parallel forces. If two parallel forces act in the same direction, here you can see in the diagram that forces P and Q are acting in the same direction. They are acting in the same direction. Therefore, these two forces are called as like parallel forces, and the resultant of these two forces is R is equal to P plus Q. The simple addition of these two vectors gives the resultant of the two forces. Then we'll say what are unlike parallel forces. What are unlike parallel forces? If two parallel forces act in the opposite direction, then they are called unlike parallel forces. The two forces are acting in opposite directions. Say here. So force P is acting in this direction, Q is acting in the opposite direction. Here you can see, therefore these two forces are parallel but the directions are opposite. Therefore they are called as unlike parallel forces. And the resultant of these two forces is R is equal to P minus Q. The simple subtraction between two forces gives us what is the resultant in unlike parallel forces. Now we'll see what is moment of a force. I'll see what is moment of a force. So the definition of moment of force is the turning or rotating effect of a force is called moment of force. The turning or rotating effect of force is called moment of force. So here look in the diagram. Look in the diagram. So what is here? I'll draw the diagram on the screen so that it's easy to understand. So suppose this is a body. The body is fixed at this point O. The body is fixed at this point O. Suppose a nail is fixed, and if I apply a force in this direction, so what happens to the body? Does the body moves or the body rotates? The body in this case rotates in this direction. The body rotates in this direction. Why? Because the body is fixed at one point. The body is fixed at one point. Therefore, this rotating effect of this force, the rotating effect of this force is called as moment of force. The rotating effect of this force is called as moment of force. So how do you calculate moment? How do you calculate moment. So first I'll give you the example of where does the moment works. So we all have seen door and the handles of the door. We have seen door and handles of the door. So handle of the door is fixed at one end. Door, suppose this is a door, the door is fixed at one end and the door rotates through this, okay, along this point. The door rotates along this point, and we have handle of the door at this point, okay, handle of the door at the far end. If the handle is somewhere here, is it easy to push or difficult to push? Yes, it is very difficult to push if the handle is here, but it is easy to push if the handle is at the far corner from the fixed position. Therefore, moment is easy if this distance increases. If the moment is easy if the distance between force and the fixed point increases. The distance between force and the fixed point increases, then moment also increases. So if we are applying force at this point, the turning effect of the door is more. But if we are applying force at this point, then what happens? Turning will not be easy. We'll need more force. Therefore, moment of a force is given by force into perpendicular distance of force from fixed point. Force into perpendicular distance of force. So in this case, what is the perpendicular distance? If you can see here, what is perpendicular distance? Distance OA is perpendicular distance, and what is force? Force is F. Therefore, moment of force is F into OA in the above diagram. Now we will see what is positive moment. If the body is rotating in anti-clockwise direction, then the moment is positive. If the body is rotating in anti-clockwise direction. So what is anti-clockwise direction? This is anti-clockwise direction. So if I am applying a force and the body is rotating in anti-clockwise direction, then this moment is called as positive moment. If the body is rotating in clockwise direction, then this moment is called as negative moment. It is very simple. If the body is rotating in anti-clockwise direction, we know how the clock moves. Anti-clockwise means opposite to the direction of clock, and clockwise means in the same direction as that of clock moves. Therefore, positive moment is if the body moves in anti-clockwise direction. Negative moment is if the body moves in clockwise direction. So we will see the two conditions for equilibrium of coplanar parallel forces. So what are we'll see what are coplanar parallel forces. So coplanar forces are the forces acting on the same plane. There are many forces acting on this plane. So these three forces are parallel with each other. Even these forces are parallel with each other as well as parallel to these three forces. So all these forces are acting in the same plane and they are parallel to each other. So if this body wants to remain in equilibrium, then what are the conditions of equilibrium? That we will see. If this body should not move, then what has to happen? This force plus this force plus this force, F1, F2 plus F3 should be equal to this plus this. What it is? F4 plus F5. So what happens? Sum of upward forces, these are upward forces, and these I say are downward forces. So what happens? Sum of upward forces is equal to sum of downward forces. Then what happens? This body remains at rest. This body, when it remains at rest, if all the forces coming from upper direction and all the forces coming from below, they have to be equal. Therefore, the first condition is the algebraic sum of forces acting on the body must be equal to 0. That is, sum of upward forces is equal to sum of downward forces. This is first condition. Okay. Suppose if this body, what I had given here, it is fixed at this point. If the force is applied, this body starts rotating in this direction. If the body is applied here, this body starts to move and rotate in this direction. So if this body should not move, then what should happen? That this moment, this turning effect and this turning effect, both the turning effects must be same. Therefore, what should happen? Both the moments should be same. So if I take this moment as positive moment and this moment as negative moment, then positive moment should be equal to negative moment. If there are many positive moments and many negative moments, so sum of positive moments should be equal to sum of negative moments. So that is our second condition. We'll see that the algebraic sum of moments must be equal to 0. That is, sum of positive moments is equal to sum of negative moments. So in this diagram, you can see that force F1 is acting here, F2 is here, F3 is here, F4 is here, and F5 is at this point. F5 is at this point. So if I want to say which are upward forces, then I'll say F1, F3 and F4, they are upward forces, and downward forces will be F2 and F5. So what is the first condition? Sum of upward forces is equal to sum of downward forces. F1 plus F3 plus F4 is equal to F2 plus F5. Then I have to calculate what is moments. So if I take these all three moments as positive moments, okay, all three moments as positive moments and these two moments as negative moments, then what happens? F1 into OA plus F3 into OC plus F4 into OD is equal to F2 into OB plus F5 into OE. So sum of positive moments is equal to sum of negative moments. So these are the two conditions for equilibrium of coplanar parallel forces. So this completes your first unit. So I'll be starting with unit 2 in next lectures. Thank you.